Hello students, today the topic which I have taken up is matrices. Well, matrices is a topic which you already have knowledge about it. In class 10 you have studied something about matrix. Actually in class 10 you have studied very basic things about matrix. What is matrix, order of a matrix, then types of matrix, how to add two matrices, how to subtract two matrices, multiply two matrices. These are the things, basic things, that is mainly the algebra part of the matrix you have studied. There are many more concepts about matrix which you need to study in the future course of your study. Well, we will focus here is the syllabus which is prescribed for your ISC examination for the coming ISC examination 2021 is, first of all, you have the algebra of matrices, what you have already studied in class 10, its revision, its backup. What we have new in this class 12 is about, first of all, is transpose of a matrix, which we shall deal with just now. And next is the elementary operations of matrix and inverse of a matrix. Before that, once again a reminder to all of you to share the video and subscribe if you are new to this video. Let us not waste much of our time and begin with the concept, that is a new concept, but what we are going to study, that is elementary operations of a matrix. To understand the concept, let us take with a example, with this example of a matrix. Let us recall, this matrix has how many rows and how many columns? Obviously, the horizontal numbers are known as the rows, so it has 2 rows and 3 columns. 2 rows, 3 columns. Now, suppose we do some operations. What does operation means? Means suppose we interchange. Actually, what is matrix? Matrix is the arrangement of numbers and which is kept in inside the braces, and this arrangement is known as matrices. Suppose I do some operations. What operations? Let us take, for example, if I change the first column and keep it in the third, and the third one I place it in first, and I write a new name for the matrix. That is what I said. 2 I am writing. The first column elements I write in the last. That is 2, 3 I write here, and 0, 6 I write here. The middle one remains as it is. Then I am getting a new matrix from the same numbers. Next, suppose I write the first row elements in the second row and the second row elements in the first row. That is 3, 9, 6, 2, 4, 0. Right? So I have obtained this matrix C from the matrix A. What I have done? I have just interchanged the row. First row to second, second row to first. Let us take another one. Suppose I multiply the first row elements by 3. I am multiplying the elements of the first row. What are elements? 2, 4 and 0. I am multiplying by 3. So 2 into 3 is 6. 3 into 4 is 12. 0. And the second row elements I will keep it as it is. I get this particular matrix. Clear? Next. So what I am observing is, I am getting this matrices from the given matrix A by applying some operations. These are known as elementary row operations or elementary column operations. When I am doing some operations within the row, then it is elementary row operations, as I have done here. I have interchanged, then it is elementary row. Here I have interchanged a column, it is elementary column operation. Here also I have done some operation within the row, means I have multiplied by 3. So it is elementary row operations. Another one we can say, that is, suppose we take a matrix E. What I am doing? I am adding to the second column, let us write it by C1, C2, C2 I am changing by twice C1. Now just observe this notation. What I have done? I am changing C2. How? By adding to C2 elements twice the elements of C1. So what is twice of C1? That means 2 2s are 4 plus 3. So let us form the new matrix E by changing the second column elements. Second column is 4 9. Here it is 4 9. This is the main matrix. From here we are going to get the matrix E. 4 9. How I am going to change? By multiplying every element of the first column with 2. The third column remains as it is. We have 3 columns. First column, second column, third column. Third column remains as it is. So let us first write down the third column since it will not change. Even the first column does not change. So 2 and 3. What is going to change is only the second column. So I will multiply every element of the first column by 2. 2 2s are 4 plus the elements of the second column. 4 plus 4, 8. Then again I am multiplying the number 3 with 2. So 6 plus 9. 6 plus 9 is 15. So what I have done? I have multiplied 2 with the first column elements. 2 2s are 4 plus 4, 8. Then 2 3s are 6. 6 plus 9 is 8. So this matrix E is also obtained from the matrix E. So what we have noticed here is we get the matrices A, B, C, D, E from the matrix A after applying certain elementary operations. So elementary operations will be of 3 categories. First one is either we change the rows to the in between the rows we interchange, or we change in between the columns. This is the first one. Means interchanging the position of the rows. Means first row I change to second row. So in that case, what is the notation? Suppose I change the first row to second row. Then we write like this. This is very important. By rotation, notations is important. By looking at this, we understand what operation we are going to perform. If I write C1, C3, that means C1 is placed in place of C3 and C3 is placed in place of C1. Now, this is the first category, that is interchanging of the rows or columns. Second one is multiplying a row or a column by any particular scalar number. That means suppose C3 I am changing by writing thrice of C3, or R2 I am writing as twice of R2. That means multiplying a particular row or a column by a particular scalar number or any number. Next, this is the first category, this is the second category. And the third category is what I have explained here. Suppose I change any row, say row 3. Suppose the matrix has 3 rows, not in this case, 3 rows. Then row 3 I am changing by writing row 1 plus or minus plus say 4 times row 3, or 4 times row 1 plus 3 times row 3, anyone we can take. So these are the 3 categories under which the elementary row or column operation is defined. Now what is the utility of this? With this elementary row and column operations, we are going to calculate, or we are going to find out the inverse of a matrix. Now we should know what is the inverse of a matrix. Let us see. Now to understand the concept of inverse of a matrix, I have taken up 2 sets of examples. Let us take this one. See, A is this matrix, B is this one. Now if I multiply A and B, A, B, what it will be? 2, 5 1, 3. 3 minus 5 minus 1, 2. 2 3 is 6 and minus 5 and 2 minus 5 minus 10, 5 2s are 10. 1 3 is 3 minus 3 minus 5 plus 6. This comes to 1 0 0 1. What type of matrix is this known as? This is an identity matrix of order 2, second order. So we can write like this: 2 cross 2, 2 rows, 2 columns. Same way, if I see CD, 2 minus 6, 1 minus 2, and minus 1, 3, minus half, 1, what I shall get? 2 into minus 1 is minus 2, minus 6 into minus half is plus 3. 2 3 is 6, minus 6, 0, minus 1 and plus 1. So this is 0 and again 3 minus 2, 1. So this becomes 1 0 0 1. So what we have noticed here is, by multiplying two matrices A and B, I get a identity matrix. Here also, by multiplying C and D, I am getting an identity matrix. So B is such a matrix. When multiplied with A, I get an identity matrix. Here B is known as the inverse of A. Same way, if I multiply BA, that also I will get identity matrix. AB equal to BA will get identity matrix. Same way, DC and CD will be an identity matrix. So inverse of a matrix A will be a square matrix. Always remember, the inverse of a matrix exists only for a square matrix. Inverse of a matrix A is denoted by A to the power minus 1, A inverse, which is equal to, which is such that A inverse into A equal to I, or A into A inverse. This is the definition of inverse of a matrix. So I think the definition of the matrix is clear. That is, A inverse into A will be equal to A into A inverse. That will be an identity matrix. Now, you may be thinking that how to find out this matrix. That is what we are going to learn from the previous concept which I just now explained. That is elementary row operation or elementary column operation. So we are going to apply either elementary row operations throughout, or we are going to apply elementary column operations to calculate the inverse of a given square matrix. Let us see how it is done. So we shall find out the inverse of this particular matrix A with the help of elementary row or column operation. I shall take up column operations. See, there are many ways of finding out the inverse. First, so we shall understand how to find out the inverse by elementary operations. So we know that any matrix A can be written as the identity matrix of the same order. I have told you that we can find out the inverse of only square matrices. Identity matrix of the same order, it is a 2 by 2 matrix, so this identity matrix will be also 2 by 2. Identity matrix means the diagonal elements are 1 and the other elements are 0 into A. Means if I multiply the matrix A with identity matrix, the matrix remains same. So we can write accordingly: 2, 3, 5, 7 equal to 1, 0, 0, 1 A. Now I am going to apply elementary column operations on either side of the equal to. So what is my target? My target is, if I can convert this identity matrix after elementary column operations into another new matrix, so that the product of that matrix and A becomes an identity matrix here. Because whatever operations I apply in the right side, same thing has to be applied left side. Then we will get this matrix, the new matrix which will be formed, that will be the inverse of A. Let us see. So let us take in this way. So we change C1 by C1 minus C2. This first column minus second column. So this becomes 2 minus 3, that is minus 1, 5 minus 7, that is minus 2. The second column remains as it is. Same thing here, 1, minus 1, 0, 1. This remains as it is A. You do not touch this. This is the rule of elementary column or row operations. Next, what we are applying is C2. I am changing to C2 plus 3C1. C2 plus 3C1. So second column I am going to change 3 plus thrice C1. First column remains as it is because the change is only in the second column. So 3 plus thrice, that is 0. Then this is minus 6 plus 7, that is 1. This side it will be, first column remains as it is. So 1 minus 1, we leave it as it is. Then 0 plus 3, that is 3. 1 minus 3, that is minus 2. Okay. Now our target, we should proceed in with the thing keeping in mind that we should try to bring the left side as a identity matrix. So identity matrix means diagonal elements I should try to bring 1 and the other two elements we should try to bring 0. So next operation that if I apply is C1, we will change C1 plus twice, because if I multiply 2 here, 2C2. Keep in mind, if I am applying column operations throughout the question, throughout the solution, we should apply column operations. So we get C1 we are changing. C2 will remain as it is. So C2 let us write as it is. C1 minus 1 plus 0. So minus 1 minus 2 plus 2. 2C2. So this is 0. Let us see here. C2 remains as it is. So 3 minus 2 we leave as it is. A. Now C1. Here it is C1. 1 plus twice C2. 6. 1 plus 6, that is 7. Minus 1 plus twice C2. Minus 4. That is minus 1 and minus 4. Minus 5. So this will be 7, 3, minus 5, minus 2. Okay. Now only thing which is now disturbing is minus 1. Then it becomes identity matrix if I can remove this negative. So what I am going to do is C1 I am changing by minus 1 into C1. So this becomes 1, 0. Means I am multiplying the first column elements by minus 1. 0, 1. Here also first column elements by minus 1 is minus 7, 5, 3, minus 2. So we have arrived at the solution. So we have got the left side as identity matrix, right side this matrix. Let us name it by B. That is minus 7, 3, 5, minus 2. This is known as the inverse of the matrix A. Let us see one more example to clarify your doubts better. in this example we shall try to apply the row operations to calculate the inverse. Matrix is given 1 minus 1 2 3. So the same procedure, the matrix can be written as the identity matrix of the same order into A. Now if I apply the operation R2 as R2 minus 2 R1. See, my target is to bring this one as an identity matrix. So R2 minus 2 R1. That means the first row remains as it is. The first row is 1 minus 1. It is remaining as it is. Here also, let us write 1 0 remains as it is. Change is only in the second row. So second row minus twice of R1. So this becomes 0. 3 minus, so minus 2. That means it is 5. And here it is 0 minus of 2. So minus 2. 1 minus of 0. So 1. Now diagonally we should make 1 and this 2 should be 0. So what we can do is R1 we have to change. Write 5 times R1 plus R2. 5 times R1. That means 5 plus 0. That is 5. So R2 remains as it is. So let us write the elements of R2 first of all in order to avoid confusion. So this is minus 2, 1, 8. Okay. This element is remaining. So 5 R1. That is minus 5 plus 5, 0. Here 5 times R1, 5 plus minus 2, that is 3. 5 into 0 is 0 plus R2 is 1. Okay, now you may be thinking we got 5, 5, we should get 1, 1. No problem, we will multiply the first row by 5, 1 by 5 and the second row also by 1 by 5. So we will apply both the operations at a time. R1 we change it to 1/5 R1 and R2 we change it to 1/5 R2. Both the operations we do it. So here we get 1 0 0 by 5 is 0, 5 by 5 is 1, and this side 3 by 5 1 by 5 minus 2 by 5 and 1 by 5. This is A. So this matrix which we have got, let us name it B or name known as A inverse, is 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. As I think we have understood how to find out the inverse. So what I was saying is, the same rule will be applied for a 3 by 3 matrix also. This was for a 2 by 2 matrix. The same rule you will apply for a 3 by 3 matrix. That means, if you apply row operations, elementary row operations, you are supposed to apply elementary row operation. If you are applying elementary column operation, you are supposed to apply elementary column operations. You cannot mix. Mix means for first one step you do elementary row operations, next step you cannot do elementary column operations. Only the target is the left side you should make identity matrix, and subsequently we will get whatever matrix it changes here, that becomes the inverse. So as the time limit for this video is very less, because it is difficult to upload a bigger video, so I could not give you more examples. Any doubt, any clarification, obviously there is scope to write in the comment box and be in contact with me. Thank you. See you again. Be safe. Utilize your time when you are at home in this crisis. God bless. See you again.